On behalf of my office and the German Center for Research and Innovation, DWIH, I'm happy to welcome the delegation of Lamarr Institute for Machine Learning and AI to the German House. So welcome everybody and thank you for being here. My office is responsible for a wide variety of science diplomacy initiatives, including multidisciplinary approach towards transatlantic research cooperation. This is our first symposium on AI, and I think it will be the first of many more. So, without further delay, I'm very happy to introduce our moderator for the fireside chat. Nina Gray is the Assistant Vice Provost for Research at New York University. She has over 14 years of research, strategy, and administration experience in roles with New York Academy of Sciences, CUNY, and NYU. In her current role, she works closely with academic and administrative leaders across NYU's 3 campuses and 18 schools to foster research and nurture a culture of knowledge, creation, scholarship, innovation, integrity, collaboration, and inclusion. Dr. Gray was trained as a neuroscientist, completing her undergrad degree in brain and cognitive sciences at MIT, her doctoral study at Brown University in neuroscience, and a postdoc fellowship at Brandeis University. Nina is a dear partner of Ruhr, and I'm delighted to hand her the reins for today's talk.
Welcome everyone, I'm so glad that you're here. I'm happy to once again be moderating an event here. I see my colleague Kurt Becker in the audience. I want to say thank you to Kurt for introducing me to so many of the wonderful organizations here at the consulate. And before I let the distinguished panelists introduce themselves and tell you a little bit about their role, I just want to say I think that this is a wonderful event, a wonderful topic to be discussing, both at the level of the technology and the algorithmic advances that are going on, but also the societal impacts and the cross-disciplinary approaches that are needed to really realize the full potential of AI's applications and benefit to our society. And I think this group of panelists is going to have wonderful perspectives on all of these issues and more. So I am going to go ahead and get started with that because we really want to hear from all of you. And we'll start over at this end. I just want to ask everyone to introduce themselves, your name, your affiliation, a few words about what you do and what your main interests are in this area.
Thank you so much. I'm Smaranda Muresan. I'm a research scientist at the Data Science Institute at Columbia University, as well as a visiting associate professor at Barnard College and an Amazon scholar. So my area of research is in natural language processing, focusing on human-centric NLP. I develop algorithms based on knowledge-aware models to understand and generate language in context, using visual context, multilingual context, and social context as well, with applications to public health, computational social science, and creativity support.
Really happy to be here. My name is R Tetreault. I'm VP of AI Research at a small company based in New York City called Data. Gotta really get in close. And my background's in natural language processing as well, and I've been an industry researcher for many, many years. If you've ever taken the GRE or the TOEFL, how many people have done that? Yes, I worked on the computer assessment. You're welcome. But also led research at Grammarly and at Yahoo, and at Data we do real-time event detection, so trying to figure out what just happened in the world and route it to the right person. And we actually have a very public partnership with the UN on this work. So yeah, so a lot of my work is on NLP, large language models, of course, and also AI for good. Thank you.
So my name is Emmanuel Müller. I'm professor of computer science at TU Dortmund University, and they're specifically addressing machine learning algorithm development. But in this round in the Lamarr Institute, I'm more in trustworthy machine learning. So we are developing the next generation of machine learning methods that's reliable and robust. As a side note, I'm also the director of a trustworthy AI research center, also affiliated in Dortmund, which is more interdisciplinary, and we are touching there also the psychological aspects of AI and how you perceive AI.
My name is Lucie Flek. I'm a professor for data science and language technologies at the University of Bonn, and an area chair for NLP at the Lamarr AI Institute. So we work on machine learning applied on generally the language technologies area, including building and analyzing large language models and asking questions about interpretability, bias, safety, robustness, personalization, adaptation, and so on. Thank you everyone for being here.
Hello, I am Felix Heide. I'm a professor of computer science at Princeton University, and I'm researching their AI in the context of computer vision and computational imaging. I'm also head of AI at the autonomous trucking subgroup of Daimler Trucks. This comes out of a startup that I founded during my PhD.
I'm Thomas Liebig. I'm assistant professor at TU Dortmund for smart city science. So we are building systems that are actually capable to use, and real-time predictions we focus on, and reinforcement learning, on privacy, on trust, and on compression of models. So quite a lot. Here in the Lamarr Institute, we foremost focus on time series prediction and trustworthy AI. And I'm glad to be here.
For your introduction. So we have a couple US universities that you may or may not have heard of represented on the panel, companies, and this very interesting Lamarr Institute in Germany. So I was hoping that one or two of you from the Lamarr Institute could say a little bit more on what the priorities of the Institute are, and what your research paradigm is for AI.
All right, I can start. Lamarr Institute is a collaboration of several great institutions from North Rhine-Westphalia in Germany that you might or might not have heard of, but that also encompass a couple of Nobel Prize winners, former politicians, and so on. So that's the University of Bonn and the TU Dortmund University, and also to Research Institute, the Fraunhofer Artificial Intelligence Institute and the Fraunhofer Machine Learning Institute, IML in Dortmund, and IAIS in Bonn, St. Augustine. And we work both on core AI/machine learning research areas and on transdisciplinary application areas. When it comes to the, we have about 40 PIs with their teams across those universities, focusing on questions around trustworthy AI, for example. Emmanuel can for sure tell you more about it later. On sustainable and efficient AI, including quantum computing. We work on hybrid AI, including like knowledge augmented models, graph modeling, and human-centered AI research involving like human-computer interaction in the experiments, and embedded AI, which includes robotics and interaction with real-world environment. And with all of these areas, I think we have international impact award-winning teams. So the embodied AI team has won robotics RoboCup challenges in the past couple of years. Just yesterday, they got, I think, 22 papers accepted on the next ICRA conference. The quantum team has recently won a global quantum computing challenge. The language modeling team with OpenGPTX is now on par with Mistral and a couple of other large models with international benchmarks, multilingual benchmarks, and I think I could name a few more achievements from the other areas as well, but without further ado, I will pass on the word to Manuel to tell you more about our research paradigm and future focus.
You heard by Lucie that was mainly the pillars that we have in which we structure our Lamarr Institute, but think of what makes it unique. Like AI is everywhere, right? So every one of you is working or participating in AI, but what is unique for us And we structure it in a triangle. That's also what you see on the website. Mainly, it's these 3 areas. The one area that you might know was the first one, was the big data, giving you the data to learn something, to structure AI technology. But in some cases, you might not have enough data. There, you might have more knowledge about your systems. That's the second area of our triangle. And the third one is contextualizing everything in the right context. So where you apply machine learning, where you apply AI, and these 3 areas couple us together and make the Lamarr Institute unique. So if you pick one of these areas that Lucie mentioned before in the hybrid learning approach, there it's essential to couple data on the one side and knowledge on the other side, and together with these 2 parts, gain more information out of your data and more information about your prior knowledge. I can give you also one quite practical example on trustworthy AI. Think of if you would like to use AI technology at the moment. And the answer is obviously yes, you would use. But would you trust in it? That's a hard question. So think of giving your child the ride in an autonomous driving car. And I particularly pick your child. Would that be an application that you would use already now? And most people would answer, I'm not sure yet. And that's what our research is all about, to make it more trustworthy. To give in specific applications like medical applications or other applications where it's really supercritical, robustness guarantees, or maybe even mathematical proofs. So I at least have full trust in math. If it's provable, then I can trust in it. Some things in AI are not provable. And that's what we are developing now in the Lamarr Institute, but also beyond that, with a lot of research collaborations worldwide, making AI trustworthy.
That's wonderful. I do think that's a really distinguishing feature. We were just talking at the table. You know, I am probably the person in the room with the least amount of actual knowledge about how AI works, but we were talking at the table about generative AI like ChatGPT, and I think knowledge and context are still missing from a lot of ChatGPT's answers. But I'm curious about the others on the panel, how this triangulation comes out in your work, and how do you see that playing a role in the AI systems and algorithms that you're developing?
I'm also from the Lamarr Institute, so I don't say something completely different than Emmanuel and Lucie already said. But I can visualize how we do this in our research. So I told you we are working on urban systems, so we're modeling pedestrians, cars, energy networks, some health data and so on, and we are controlling in these systems. We have predictions and control in order to perform better. And in such a case, you want to make predictions that make sense. That's something that you want to have. So some physical conditions you want to incorporate in your model. You have physical processes and you want to somehow condition your model on that. And once you control in such a system, you want some guarantees that your control does not make things worse. Yeah, that you can trust your control loop somehow. And we are doing this with some safe reinforcement learning, for example. And there are a couple of approaches, but I think I had ever.
So, yeah, really interesting question. So, the way how we address this in our work that's coming out of my lab is by looking at the power of generative models in the context of being able to synthesize observations that we can then test against, or can generate scenes that we can then test against an observation. So this means that we can rethink traditional vision algorithms such as object detectors or trackers that have been separable modular algorithms in the past, now as inverse rendering algorithms. We can say, hey, look, generate me an image or a video scene or tracklets that then best explain the scene. And that gives you then naturally explainable and interpretable outputs that we as humans can understand, but that we can also better analyze in downstream tasks. And so that approach fundamentally relies on both the power of generative models as well as using physical priors that are then sort of inductive priors in this approach itself.
One thing with the question is, how do you define data, knowledge, and context? And in the Lamarr Institute, it sounds like you guys have something in mind, and I don't know if I'm going to agree with you or disagree. I'm just going to start talking and see where it goes. Basically, at Data Miner, what we do is we provide breaking alerts on real-time events in real time all over the world. So it could be country A launched a missile at country B, or there's traffic backed up in Southwest Dallas, and we have organizations, the UN, federal agencies, all worldwide, that care about knowing this happened 1 second ago. And so obviously we need an AI to pull in millions and millions of signals, make decisions very quickly and accurately, and send that out to the right clients. And for us, like when I give presentations to clients or just sort of the layperson, we also have a pillar, and the data and the people aspect is actually really important for us. And we've been around for 12, 13 years now, and because we've been ingesting so much public data, this is all like we partner with it, we license with it, we have a good understanding of what happens in the world, but it also means that with the advent of these large language models, we're able to like fine-tune them to all these very particular tasks. But one thing that I think gets lost in the news is that people always talk about, oh, these models can now play Go, or they can do driving, or they can do all these different tasks, is that it was often built, and that data that it was trained on was often built on a lot of human labor. And even now, those models that are deployed, if you're using the API, a lot of work, human work, has gone into probably making rule-based approaches to putting guardrails in them, to making them safe. So I think the human part is very important, and I'm kind of constituting that as knowledge in our own work, because we send out alerts on some very, very sensitive topics. There could be a school shooting process. A lot of different agencies need to know about that so they can act accordingly. We can't afford to get that wrong. So for a lot of these, I call them high voltage types of, high threshold types of settings, we have to use humans in the loop. These are experts, journalists, State Department officials, former people of all these different areas that come in and work with the AI in the span of several seconds to say, we're going to send this out to this client. They'll know what to do with it. And the thing is, the AI learns from these interactions. And so our underlying system gets better. At the same time, the system can do more of the low-hanging fruit, so these experts don't have to do it. So for us, for our kind of task to be successful, we have to have the humans in the loop. There's just no way around it. And I think it goes a lot for a lot of companies, even if it's not explicitly said. My 2 cents.
Yeah, I can also mention something. So in my lab, we are building these natural language processing models, trying to solve real-world problem, for example, detecting misinformation, or trying to answer questions in the different fields like linguistics or public health. So for example, we are working on trying to analyze social media to understand how people move from use to misuse and addiction in the context of the opioid epidemic in the United States. So to build solutions for these real-world problems, we are focusing particularly on using knowledge-aware models, where we can include, for example, knowledge about linguistics if we are developing multilingual solution, or knowledge about the domain, for example, if you are working in the public health domain. And what Joel also mentioned, another type of knowledge we are using is building this human AI collaboration framework, where we leverage the expertise of the experts, both to build the models as well as to evaluate the output of the models using expertise.
That's fantastic. I mean, a lot of really interesting projects. So if we think a little bit more broadly about the field of AI in general, beyond what you all are doing, what are some of the most important recent advances? Obviously, you said all of the most recent advances just now, but what's the next second best?
So one thing that I really like on the recent developments, like the paradigm with the large transformer models that we basically pre-train on a range of tasks and then test them on a different task, and having them gaining knowledge from all these kind of related areas, is that it forces the disciplines to work closer together again. So like when you talk during the day today, you will see that we have here AI people working on biomedicine, we have here people working on physics applications, we have people working on computer vision, people working on language technologies, but ultimately we are all using the same technologies nowadays, and we are all dealing with the same problems, and that brings the conversation much closer across the fields, and it's opening up completely new collaborations, completely new perspectives. And at the same time, we are now seeing that we have to go beyond our comfort zone in the computer science. So when I started in the field, it was all about how do we make these models work? How do we make sure that a model produces a coherent sentence, or that the answer to a question is even anyhow related and reasonable? And now we know that we can do lots of things that work, and we are starting to ask questions like, when should we do them? Should we really use AI for this purpose? Are there purposes where we don't want to apply everything that we can do technically? And we have to work much more cross-disciplinary with ethics teams, with psychology teams, with social science teams, with economist teams to solve these questions. And that's what I really love from these AI Institute level collaborations, that we really have to look at the societal perspectives now.
Let's take the previous from your side. I liked that you said the human is the important part of the decision making, right? And I feel that's the biggest breakthrough in AI and machine learning, that we as machine learners, since 50 years, we didn't think about explainability. We thought only about ourselves and like how to produce results in a text file. I think for me, explainability is the one breakthrough that I like, particularly to answer your question, how we relate to humans, because without that, we would be like the weirdos that create algorithms that no one can use. For me, it's important that there are results that are explainable, self-explainable. It's not the human that has to understand it, it's the algorithm that has to explain itself. And I think we will see a lot of more innovation where explainability comes in by design, or other like fairness criteria and other objective functions that we like to optimize in the mathematical sense should sneak into the algorithm, and then we can create something for the general good and not only for computer science purposes.
I think also tying into what we previously discussed about humans being oftentimes sort of this underbelly of AI that are generating large corpuses of labeled data. I think this is fundamentally a problem which we have to solve. I think we have to make, as researchers, we have to make unsupervised learning really possible, and we have to make progress towards that route. Because otherwise there will always be a component that's almost bordering on exploratory practices, right? So we have to realize that we have a responsibility towards the human labelers that are offshore in very large organized labeling farms, and we have to solve that with technical approaches. And at the same time, as we said before, I also agree the algorithms have to be explainable. The algorithm has to explain themselves, like, why am I getting this result? And I have to look at it and understand it. Otherwise, I think we will have a big issue. The other big thing, I think, where we also have a huge responsibility is energy. I think looking at the large generative models that we also train in my lab, we have a collaboration with Google, and one of their data centers is using over 100 megawatts of power. And as GPUs are becoming this commodity that we as AI researchers are tied to so fundamentally, becomes a really big bottleneck. The demand is much higher than the supply of these GPUs, and these GPUs are at the moment in one company, and we're burning through all of this energy. So this responsibility and the ethics behind it also broken at the moment. So I think this is something that I want to see changing in the future.
Thank you. I'm glad that you mentioned the energy and the resource awareness. That's great. I also want to add a couple of other things. Since we are from Dortmund, I want to mention that we have not just text data, but we have also structured data. And it's a great advantage that we now can process graph structured data. So we have graph convolutional neural networks. And the reason why I mentioned this as being somebody from Dortmund is because there's a nice open source toolbox which is somehow developed within some research center in our university. Yeah, so structured data and dealing with structured data is important. So you have several kinds of data, not just text data, and you need to search a model which is appropriate for your data. And that's something we also need to incorporate, not just human beings, but also the context of the data. So that's really important. What is the context? Where does it originate from? And also, what's the impact of a particular data point? So Emmanuel mentioned trustworthiness. But I think also from a theoretic side, there are some things worth mentioning. For example, here in the US, you have development of differential privacy for quite some time. At the moment, the recent development is caution differential privacy. That's some invention which we hardly can estimate what's the impact is so far. You can somehow quantify what's the impact of this particular data point, and it provides guarantees which are the strongest guarantees on the theoretic side. So this is really something we need to look into the future and improve.
I think the question you asked, if I could wake up every morning and give a different answer, like, oh, what's been the big thing? Because there's so much that's been happening over the last year that it's often hard to track and often hard to see whether it's going to manifest as a large thing. And I remember, I've been in NLP for a while, and probably up to like 5 years ago, I could tell you generally what was happening in each sub-area of NLP, who the top professors and industry place, and now, who knows? It's just, there's so many people working in the space. I mean, and NLP, and even these large language models are now, it's less of an NLP thing and more of a thing all to itself. So maybe that's the big thing I can highlight. A couple other ones. I'm really excited about the multimodal work that's happening, and maybe that's, I know that a lot of the big players have been rolling those out over the last few months, so it might have been a bit fresh if I said this in November, but I always felt that was going to come, and I think that there's, when we think about, going back 50 years, 60 years, when, the grandparents of AI were thinking about how to really model these problems. They were really thinking about making agents that could like sense the world and interact with the world. And language is just one part, it's just one component of that. Now understanding all these different modalities, I think brings us closer to that vision, maybe in a different way than they expected. Another thing I want to highlight, as this is Monday morning, so I'll give you my Monday morning answer, is it has to do with the two gentlemen at the end. I've been really heartened by the number of open source models that have been created. I remember when, I think a lot of folks knew 2 years ago, Google and Meta and other big companies were working on these models, but they kept them in-house. You talk to your colleagues, you know that they had them, but they really weren't saying it, but you knew. And I think when everybody started hearing after ChatGPT how much it cost to train them, everybody had this mental moat in their heads. But thankfully, due to a lot of efforts around the world, there are a lot of different models one can play with and one can get started with without actually having all the resources of those big companies. So I think it's been very encouraging to actually have that going on. And don't get me wrong, there's still a lot of constraints and issues in terms of disparity of resources and equality, but just the fact that we both review for a lot of papers for NLP conferences. There's a big one going on right now. And one of the things that some reviewers will point out is like, why didn't you try Mixtral or Llama this or this one? And like, well, probably because it costs a lot of money. But at the same time, the fact that there are options for people to evaluate and compare against is really great. A year ago, I think a lot of people were very, very afraid and shaken. So I'm heartened by where things are, but I still know it's kind of going up and down.
Yeah, I think everything was more or less said, but I just want to add one thing which I think is exciting, is that these technologies are actually used by real users, and really understanding how this technology is used and how this is actually to solve the task, and evaluating evaluation protocols to figure out exactly the utility of the models when they are used by the end user. I think that's actually an exciting part of the kind of both of the NLP, machine learning, and AI. And besides the multimodal, I want to also mention multilingual, because here we are talking about collaboration across the US and Europe, but I think more generally, and trying to equip these models with knowledge about different languages and also different cultural aspects. I think that will be very, very important.
That's great. I'm going to pull on a few of these threads to try to elicit from you what we can be doing better to address some of these issues. So the first one I'm going to pull on is from Lucie on the idea of collaboration. I think we all know that most of the major societal problems we face really require interdisciplinary and international and cross-sector collaboration that includes, communities of interest and underrepresented minorities, and a lot of different factors need to go into this. So in the space of AI and machine learning and these types of approaches, what are some success stories, or what are some ways in which maybe the Lamarr Institute or other examples where there have been wide-ranging collaborations, what's made them successful? What types of resources are needed? What more could universities be doing, or companies, or governments?
Generally, I think when it comes to Europe-US collaborations, lots of the expertise and specialization comes from the fact that you guys often have lots of good data, access to lots of users, access to large-scale computing, and we historically had to specialize on making the most efficient stuff from little data and making the best stuff scaling for very diverse communities across countries, across languages, across cultures. So I think lots of the successful collaborations develop from that. In my field, in the NLP area, we see it on building multilingual models in Europe, where we are also focusing on certified AI projects, like producing guidelines for companies on how to figure out if there are biases in the data, if there are biases in the model, if the models are safe to use. Talking to the users, the institutions, working with industry-facing institutes as well as with academics. But also learning a lot from how things has been addressed in the US and what's different in terms of the European ethics and safety discourse, which often looks very, very different than in the US when it comes to data and users.
So putting on my Daimler Truck affiliated hat for a second, I think that there's been tremendous progress collaborating both between academia and industry, as well as peers in the automotive sector. Seeing all the work from robotics that has made finally its way into vehicles that are on the road already right now, level 2 systems mostly, is truly amazing. And I think this is largely due to the fact that the automotive industry maybe has realized that they will be in a really bad spot if they don't internalize themselves as being software companies in the future. So that's really a huge win, and something that has happened in the future. On the academic side, I would say the most exciting applications that I've seen always happen at the intersection of application fields, where, for example, photonics, AI, and computer science are overlapping. And I'm seeing a lot of really exciting stuff on optical computing happening right now that could fundamentally reshape how we think about processing at the edge as well as in the cloud, and solve some of these energy problems. And I think only enabling these really difficult cross-disciplinary inventions can truly give you sort of this step function improvement and really push us forward. So that's something I'm really excited about.
Yeah, the collaborations I'm aware of, they mostly are driven by exchange. Personal exchange, so a forum, you have a forum and you discuss with each other. Interdisciplinary, that's something important, and of course that's the starting point. And get some understanding for each other from different countries. You have one country and the other, and so on. That's fine, but in the end, most collaborations which are really last longing, they are run. They are driven somehow by persons. So somehow you have persons going from one place to the other. And that's for several reasons. Some of them are not nice, but there are some reasons why persons need to switch relations. And nevertheless, that's good for collaboration. And that's not just good, that's necessary. And therefore, we are here and we have a forum, we discuss, and that's quite nice.
You asked for examples, and maybe I can give you two for the Lamarr Institute. So one of them would be interdisciplinary in the sense collaborating with mathematicians. So if you aim at explainability, for example, game theory is a big toolkit that you can exploit. And we do that collaborating between computer scientists that develop the machine learning methods, but also game theory from the math department. We are doing that particular project with the university clinic in Bonn, so where we have data from the medical domain and we try to explain these patterns to doctors. And the other example I would use is, again, from your side, so great inspiration that you give me from the right. So it was about your open source comment, because we do open source releases of all of our algorithms. So I could be proud of it, but for today I'm more, as you said, every day a little bit different. I would be more afraid of it. Because we are releasing everything open source, but this means everyone can use it. Sometimes if I hear and get the emails for the libraries that I pushed open source, and I get the stupid request by email, I realize how really lay people use this without knowing anything about machine learning. Particularly, they don't know how to train and how to evaluate these methods. They mistrained our own algorithms, and then they might get really in severe trouble. That's why I would say also open source has its benefit, but it also gives us, as the community that invents these things open source, and I'm very much in favor of it, gets the responsibility to make the algorithm such, not only self-explainable, but also giving it a label, giving it the energy consumption label, how much energy it costs us, how the quality criteria are, and all of this should be like marked for each algorithm such that we can safely outsource to the general public. That would be my vision into the future, what we need.
This is, again, one of those great questions where there's lots of different ways of answering it. I love your answer, by the way, because it is true. Like, you put it out there, well, then you have to deal with the emails, first of all, right? but yeah, you don't know who's using it, and that, there's goods with the bads. I think, I was sort of sitting here, and the question you asked is like, what makes a successful collaboration? I was like, well, what does success mean in this? And I think you can probably talk to everybody in this room and everybody's panel, and everybody will give a slightly different answer about, well, what does success mean to have these models out there? Who can use them? What are the guardrails, et cetera? That might actually be the next question. So that I get a little hung up on that, but I will say something at a very tactical level to contrast with all the great answers here. Was, we did a collaboration with the UN Office of Human Rights a year and a half ago, and they had a problem, and of saying, like, we want to be able to detect attacks on human rights workers all over the world. This allows us to, like, collate this information, aggregate it. They want to detect it from newspapers, and develop reports and say, are these areas trending or not, et cetera. And like right now we do it manually. And they had a couple people who did a little bit of data science. So they said, could you help us? Because we already were working with them. And said, all right, we can build a model for that. And there's a lot of ways that can go in many different directions. And one thing I learned from that was very fruitful collaboration. And we do many of these. I've seen them, some of them almost as good, some of them not as good. And I think what helped out in these situations where you're not collaborating computer scientist, maybe computer scientist to layperson, is, this sounds generic, but you have to be able to communicate with each other, have common goals. And we were fortunate that they knew enough about data science to be dangerous, but also understand things and pick stuff up themselves. And like, we had known enough about working on these types of tasks because we had that experience. And I think that goes a long way in terms of like, we could have presentations, but it didn't happen overnight. Like, we really worked on a shared vocabulary, on like a shared time frame for things. And it's a slightly orthogonal answer to your question, but sometimes when you talk about collaborations, it doesn't matter if you're collaborating on like science or marketing or whatever, it always comes down to communication. And I think especially, the stakes are kind of high here, and this goes exactly to your point of like, how do you make sure the folks on the other side are understanding you? How do you make sure you're understanding them?
I want to add that just this funding mechanism that bring together the domain experts with the AI technologies, I think that's very important. And in the US, for example, that can be the National Science Foundation AI Institutes that are bringing together people from different institutions. And I also want to advocate for kind of funding from the government for compute resources, because a lot of the compute resources are now in the big tech companies. And I think, for example, New York State currently just have an Empire AI, which is compute resources for the university and the small companies, which I think is going to be very important for developing AI.
Yeah, that's an interesting collaboration model that, in case you don't know, the state coordinated with, I think maybe, so all of the SUNY system, the CUNY system, plus Columbia, NYU, Cornell, University of Rochester, they're going to build this massive, data center, HPC, resources out in Buffalo for like the entire university system of New York State. It's amazing. And yet, we're here also thinking, well, in 5 years, when it's going to be completely out of date by then, and how are we going to get the next X millions of dollars in order to update it? It's impossible to keep up. But so yes, well, we're going to kind of get to that, I think, in this next question too, where the other thread, it's really many, many threads on the sort of ethical implications of AI and how those are being addressed, and from whichever of your favorite or most concerning ethical issues, I'd appreciate your perspective on how you think what you think the responsibility is of the AI community itself, what you think the responsibility is of the governments involved, what you think the responsibility is of industry in addressing those ethical concerns.
So I think of course, there are a lot of ethical consideration, and I think we can go from bias, fairness, equity, privacy issues. And I think developing and really focusing on this human-centered AI, where you put focus on human agency and oversight, I think that would be very, very important, both from the technological side, but also from the policy side. So, yeah, there will have to be.
I actually agree wholeheartedly with that. To answer your question very quickly, like you say, where should the responsibility and the onus be placed? I think, if you really want to be ethical, however you want to define that, it doesn't happen with one group. All groups have to be taking responsibility for that. This can't happen in one place. Otherwise, it's going to break down.
Maybe I would not like to push responsibility away from us. We as scientists have the same responsibility, everyone has it. And we from the European Union have now an AI Act. You can debate about that, but it also shows us that we have to take care of that. And maybe regulatory aspects for me as a scientist are not the only way we need to touch upon this. Like we had the explainability issue that you mentioned, the human interaction issue, all these things together. And maybe if I give you an example, we are also doing a little bit of discussion with the politics in North Rhine-Westphalia about the new education system in Germany. How would you educate high school students in AI technology? And this is also a very basic responsibility that we have. And I'm not saying that only as a father, but also as a scientist, like we need to push this into the lowest level of education. If we don't do that, kids will do that alone. And like ChatGPT being a very nice example where people use it, kids use it without knowing what it's about. That's not the problem. They can ask me, but in some cases they don't have anyone to ask, and even the teachers, they don't know about it. And that's also a responsibility we have to teach the teachers about a new AI technology that they are not aware of. And yeah, we are as fast as we can, but we should be also as fast as we can in the education system.
I would completely agree and wholeheartedly subscribe to that. I think it starts with education. I think engineering ethics is something that we found a little bit of a back burner position at this point, but it's fundamentally of really big importance if you want to make sure that future algorithms, future machine learning systems are developed in an ethical way. And I think we can only make that happen in a scalable way if we look at education of the of the engineers. And perhaps we can draw some analogy from other fields, right? If you think about our field having to use these very big machines to make progress, to make scientific findings, maybe there's an analogy to physics, right? Where there was also the danger of building potentially very destructive techniques in the past. And so we can draw from how physicists have been dealing with this, mostly building on a solid foundation of engineering ethics. And you see that in some of the universities, for example, right? University of Waterloo in Canada, they have this ring that you get as an engineer that bounds you to your ethics. So finding a spot in the engineering education to bring into the front, again, engineering ethics may be a really important piece.
Yeah, the education, one goal of the education is also somehow to help some informed decision, how to build such an AI system, how to use ML technology within the system and so on. And in order to come to this point that you make an informed decision, you need some kind of labels. For example, the energy labels, that's one direction to go, but also to deal about the certification of AI. So you have several applications where certification definitely makes sense. And accountability is an issue. If you think about AI for governmental things, there are many applications for this, but eventually you want to have some accountability in these applications. And all these processes need to be defined. You need some, Emmanuel said, some proofs are some nice things in these domains, or some discussions, at least some discussions. In order to discuss these topics, you also need education. You need educated people in order to make educated discussions, and so on.
I couldn't agree more.
Yeah, I can only second that. Basically, that when we do our explainability research, where I think explainability is the key to safety and fairness, we have to ask explainability for whom. And now with all the models getting more mature, we see that it's not just about doing explainability for machine learning scientists in terms of us at least understanding what the models are doing, but we have to ask, does it mean explainability for general audience? And we had outreach activities for various diversity group who are not early adopters of these technologies. We were in summer schools. We have educational programs in various institutions in the area. And we see that transparent systems, as they are perceived for computer scientists, are not transparent systems for everyone. We have to tell people, what does this mean? What should I be afraid of? What I shouldn't be afraid of? And also educating the teachers, for example, is one of the areas that we have to address now.
Since we've already talked about how important it is to educate everybody at all levels, really, on AI, how do you think AI is going to transform education?
So we do this with the North Rhine-Westphalian government at the moment, and the discussion we have there is both from the computer science perspective, but also from the educational perspective. And people in education, they want to personalize education to the one person that you have in front of you. And AI can definitely help in that perspective. By data analytics, although it has some privacy issues in there as well, but if you solve that, okay, then you have a more individualized perspective on your school students. And that should be possible. The help of AI technology in minorities, for example, there is special programs that you can use to get like extra lessons on that. And that was one key example where they said the US is by far better in that respect. All the examples that I heard in that meeting came from CMU that we visit in a few days. So it seems for me that the US system has a little bit more advantages in there because we in Germany are a little bit more afraid on touching with this technology and our kids touching on this technology. The problem with this in Germany is that the kids will do that anyway, if we care or if we don't care. So we should care, and that's why we try now to change a little bit the system and make these tutorials for the teachers such that they can, catch the low-hanging fruit. We don't want to build up a new curriculum we want to make basic education possible for the teachers. That's something we will start basically next year with a new program, which is funding in North Rhine-Westphalia for schools to apply, and then experts like we have a nice program within Lamarr. It's called AI for School. They can then get the funding to pay this program in order to get educated.
Anyone else want to venture?
I think I agree that we shouldn't prevent the students from using this technology, and that they are super motivated using this on their own. And I think all of us probably see it when correcting bachelor and master theses these days, who use very exotic words in every second sentence. So I think students do want to use it at all levels, even like small children. The barrier is usually at the middle layer, like educators, school directors who are not sure how the infrastructure should work. Like, do they need to get everybody access to American company APIs and pay that from German state money? Is that allowed? Is that possible? Do we need models made in Germany to make that possible at schools? So we need to have infrastructure discussions. We need to have educational discussions at the infrastructural level rather than supporting the students directly. The students, they want to do that.
I have maybe it's more of a concern, which is, I mean, we can teach people how to use this. I think the concern I have, and again, this is, to Lucie's point, we see these essays that come out, and I have a friend who's a linguistics professor who teaches seminar classes where people have to write essays. She says, like, everybody's just using the technology. I can tell. I can't tell you why I can tell, but I can tell. And it's this very neutral, bland language that comes out and might have been touched up here or there. And I think my concern is more on, like, what do people learn and how do they learn? And maybe this is saying something about, the time area, epoch that I was brought up in, but, you learn by struggling through things. You learn by actually trying it out and failing again until you get it. And that's satisfying, but you get it. Whereas now, it's just, I can just ask the machine, and it's going to be right, most of the time, right? Or if I'm in a hurry, I can just do that, get that one assignment taken care of, and it's a bit of a slippery slope. And I know maybe taking a very pessimistic look at it, and there's some very optimistic and positive things, but I think less about maybe the framework and the infrastructure, but what does it mean for our children to be learning right now when they're going, and what is their life going to be look like 20 years, and what is AI going to be looking like? I don't have an answer for that, but I feel like, they should know how to do things and not feel like they have this crutch at all times with them. That's uncontroversial, controversial. You can throw stuff at me after lunch.
I mean, I think it's still a question that all teachers and educators are facing right now, is how much to allow and how much to try to avoid or get around the use of generative AI tools. And I mean, I have my own. They're going to use it. Figure out how to challenge them in ways where using it isn't enough to get a good grade. It's hard work for teachers that have not had to work in that kind of space before.
Another aspect I want to add is, particularly for our graduate students, is that they are now aware how to present their research at the conference, but now I think they need to learn how to communicate science communication to the general public as well, because I think we need to get away from the hype, and we need the technologies to be able to explain to the general public what are the capabilities as well as limitation of the technology.
Yeah, and improve trust in science, not just trust in AI, but trust in science and scientists as well. Joel said he can't answer what AI is going to do to our lives in 20 years, but I'm going to challenge you to answer in 5 years. What do you think will be different about the way you do your work or live your life in 5 years because of AI advances? Just one out of the dozens and dozens of things that might be possible.
So I would hope that in 5 years from now, we're going to see much more robotics that's driven by AI. So not only really truly self-driving cars and trucks, but AI in an assistive robotic sense is something that I'm seeing a lot of work being done in, that companies have also embraced, and that it seems to be hopefully next unlocked by being able to generate enough data. That would be something that I think could fundamentally transform transportation and how we may live and look at elders, for example. Right? So there's lots of really exciting opportunities there, if done in the right way. If it's negative, if it goes in the wrong way, we live in a world of war machines. So there's the ethics question there.
Quick answer, a very selfish answer. I would like in 5 years to have a self-driving car that gets me from one place to the other, because all these meetings are really, really time-consuming by car. So that must be a selfish answer, and then I could read more papers in that car.
If I can add, on my wish list is more efficient processing of knowledge, because if we still look at how much data machines need to process to learn anything, like how many times they would need to read all the Wikipedias of the world and the entire internet and all the libraries ever to produce a meaningful sentence in the answer, I think we can do it as humans much better, and we can get back to kind of knowledge processing and knowledge injection to the systems and smarter ways, getting back to the roots of the traditional symbolic AI and combining these like process-focused, algorithm-focused, step-by-step learning with the huge data-throwing statistical approaches to get to something more efficient.
In 5 years, I hope that we have somehow some ecosystem where we can build up some AI services, and we can somehow make some data economy and somehow make processes that actually make sense. So not that we have some organization that has data and we have a university or some consultant that analyzes this data. That's working, but that's not something for future. In future, you need somehow a company that has data somehow consuming a service from somewhere that does something meaningful. In a privacy-preserving way, of course, you don't want to provide all your data in a trustful way, in a certified way, whatsoever. You somehow need to make an informed decision, and somehow this federated ecosystem, data ecosystem, we would like to have in 5 years, and we are currently working on it. In the long run, I really hope that resource-aware computing is getting better. So, for example, we have all these quantum ML studies at the moment. I really hope that this is something in the direction that we have some special purpose computer, like with GPU, you have somehow QML that is resource-aware for certain problems. And also, for example, wetware, yeah, your brain is using much less energy than large language models at the moment, but it's more powerful. So eventually wetware and some special purpose computers in this direction also makes sense in the long run.
I can think of a small one and a big one. I think a small one, and like there's been kind of dips and step functions over the last 30 years on this. And academic and industry places love to work on the personal assistant, but it never has panned out. But like I feel like this is really going to happen for now. Like it's really going to happen in the next 5 years, where I can just say, whatever the computer's name is, just book me a flight to Dallas for the eclipse, get me something that leaves in the morning, Delta, LGA, sort it out. It has to be under $1,000. Like that is, and then it will know how to do that. And there's already work over the last 6 months on connecting LLMs to APIs. And there's obviously all the work with Siri, et cetera, that has AI in it, doesn't have AI in it. But I feel like a general purpose model that can do these types of tasks, which we can do them, but it's always like 10 minutes here, 15 minutes there, it just starts adding up. Like I think that's going to be easily within the realm of the next few years. I will take bets on that. The other one is, we have some takers. Another one is thinking larger. Like we've been talking a lot about just how these models work and the impact on society, but I feel like for the next 5 years, we're going to see a lot of breakthroughs in medicine, informatics, climate change. I love that, and it's going to have AI in the title, in the news title, and I feel like that's what I would love to see, and so I'm cautiously optimistic on that.
I think maybe in the next 5 years, like really getting this access to multilinguality, so wherever you go, kind of to get access to assistant in many languages. And I think what I really want to see is like really the role of AI in scientific discovery. I think that will be the next big thing I would want to see.
Fantastic. So we are at time for our panel. We're going to move on to the next phase of the afternoon, but I want you to join me in saying thank you to these wonderful panelists and all the great ideas and thoughts that they brought today.
Thank you so very much for this active and engaged conversation. And in lieu of Q&A, I invite you to go back to your tables and have, I guess, the next half an hour with coffee, desserts, and conversations. Thank you.